What's going on, everybody? This is Jake over here at the Grand Solar Minimum channel. Tonight we have the big picture with Lee Wheelbarger, like always. Mari hanging in the background, correcting my mistakes. Hopefully, I don't have too many tonight. Lee, how you doing tonight, bud?
Doing great. Thanks for having me.
As always. Um, Quickly, just before we get going, we had some video footage. Mari did a great job putting some extreme weather footage together from the past 3 weeks. But first, I wanted to talk about something. Before we went on the air, I was kind of just browsing the internet I wanted to see crop loss for myself. And I went as far as bookmarking these two articles into my phone so I could have easy access to it. The first one talks about the um, the freeze that the southeast got this year, and some of the things that were described in the article from the writer. Let's see here. I just want to read real quick. The orchard owners and experts alike were shocked and disrupted by this occurrence, and it was talking about the extreme temperatures that wiped out devastating large portion of Connecticut's fruit crops. And it goes on to say, this is quoting a farmer, "We lost an entire peach crop and over 50% of our apple crop." He also goes on to say he has never seen anything like this before. Last year, February saw unusually warm weather, which was immediately followed by below freezing temperatures that reached near 0 degrees in some parts of the states. So here we're talking about an entire peach crop. Half of their apple orchard is wiped out. Here we go. More quotes from farmers. Never seen it like last year. Spring frost is common, but last year was earlier and more severe than ever before. Okay. And I wanted to point this out because the next story I'm going to share with everybody is this is the Southeast story. Okay. Sorry, that was the Connecticut one. Here was the one that was in the South. We had that deep freeze. And basically, I'll read here from the article. Georgia blueberry fields fell in a deep, damaging freeze. Is it the worst over? And that question is the question of the hour. And the farmer was quoted saying, "If it's not, I might as well quit." All this week, overnight low was in the mid 20s. Some good news. Thursday's low should stay above freezing. They were talking about earlier in the article about how the strawberries were actually a whole lot worse than I expected. The way this winter system slammed into the southeast down here, it came down hard and fast. 1/3 of his strawberry crops were lost to this. It was a bad night. He was quoted saying, "Yeah, and the plants took a beating." Drew Eccles is his name, who lost more than $1 million that week. Now, this is just in the southeast, just in this small area that saw that late cold blast that came through.
And that's one farmer.
Yeah, one farmer.
Right.
The two things that I'm tying together here is both farmers, both parts of different parts of the country, one up north, one in the south. Both of them, the reporter and these articles, the last one I just told you was from March 16th. The first one I read to you guys was from May 2nd of this year. And both reporters in each of these articles, separate news channels, we'll put the links in the article in the description box. But I found it interesting that the reporter focused on the emotion and the surprise out of these farmers. And to me, this is part of the problem with the truth not getting out, is that the shock and awe of the effects, and we're just in the beginning, folks. This is only the tip of the iceberg.
Well, now, forget the shock and awe. Look at the devastation that it does to that farmer and his family. And will he be in business next year?
No. And he even says if this continues, why I might as well quit. And that was
Right.
just from one. That was just from one event, Lee.
Right.
I believe the Southeast stayed cold for a few more days.
Yeah, it's only going to. More and more farmers are going to be facing this all over the world.
Lee, you have a background in farming. You know what kind of funding is available to farmers, and how long can the government support these guys on this type of funding?
Well, there's a variety of different funding for supporting crops, milk. There's subsidies that you can get to support the farmers. But when you lose, and of course you've got crop insurance to help you, which most everybody is going to have to use, that's been impacted by this year if they had it. But the problem that we're going to have is it's not just the farmers that are going to eat it. The insurance companies are going to eat it too, because they're the ones that have to pay for the crop losses. And those crop losses, as well as other losses caused by all of these storms, are going to put insurance companies out of business. There is no insurance company in the world that is going to be able to handle all of the claims that are going to be coming. It's just not going to be. It's not going to happen. The damages because of floods, the damages because of earthquakes, the damages because of volcanic activity, the damages because of hail, high winds. The insurance companies are about to take a beating like you've never seen, because we're talking about apocalyptic type weather worldwide, and who is financially responsible for covering that? The insurance companies. So that's the industry I would be getting out of.
Well, and when you saying that, that's going to mean premiums are going to shoot up. I mean, it's almost not going to be affordable anymore.
It won't be. It won't be. At no cost will it be affordable. Okay, there will be no, because once this starts happening, the claims are going to far exceed what the people are putting in as far as their monthly payments. Your likelihood of having a fire. I mean, I don't know if it's changed much since I read the data, but when I went to college to be a firefighter, a house has the chance of some type of a fire every 7 years on average, is what it used to be. What it is nowadays, I don't remember. But the risk is going to be substantially higher, because as we move into more earthquake activity, these more dramatic storms, increased hail, atmospheric compression, places being washed away, these unbelievable lightning storms that are killing herds, that are killing people, and I'm talking groups of people. It used to be, you might get one or two or three, and if it was really crazy, 6 people. Now you're getting 63 people, 67 people being killed by a single, lightning bolt. 232 reindeer killed by a single lightning bolt. So all of these things are going to be much, much worse on the insurance companies, because they're the ones that are going to have to cover the losses.
I just got a news alert, and I'm going to try to find it here. This just happened, apparently. There has been an earthquake in the Greek islands in Turkey today.
Yep.
2 people have been killed and more than 100 have been injured from this event.
Yep.
I believe it hit a 6.7. Yes, 6.7 was what the rating was on it. There has been more than 20 aftershocks recorded at a magnitude of 6.3. We do have a solar wind stream heading our way as early as midnight tonight, possibly.
Well, you'd have to look. I haven't looked at it today to see what our magnetosphere is doing, or how energized we are at this particular moment. All I can tell you is during a colder climate, volcanic activity, seismic activity both increase dramatically. The majority of the time in the first part of the minimum, as the Earth is starting to cool. So now is the time for unbelievable amounts of seismic activity. Do we have questions in the chat?
I actually wanted to ask you one more.
I just want to play it in the background. Just to play it in the background.
Yeah, ask whatever you want.
So we have some footage.
Well, it's 5 minutes long, so you have plenty of time. You can just let it play and just do what you think.
We have
This is the
some
crazy
footage
weather.
playing. I can't tell if it's playing.
One of Mari's masterpieces.
Mari put this together for us. I don't know how to operate it because I'm a retard. So I apologize, folks. Here we go. She's got it going for us. So I took this footage right here, and I apologize for the footage. I did not know to turn the camera the other way, so I apologize. This is crappy video, but I had to grab it real fast. But we're here in Buffalo. We don't get this kind of rain, apparently, to some of the locals that I've spoke with and Mari. And I just found it interesting to see. This was just about 25 minutes into the rain that had fallen.
Yeah, your storm system there is definitely running at capacity.
Now, it rained like this last Thursday, and I did not see the kind of issues that they were having today. And how fast the rain fell, it was, let's just say my shoes were wet. They were almost covered. There was no area to walk out in the parking lot where water wasn't flowing through it. And it came down. It was like that within, I don't know, 20 minutes, maybe less.
Well, it's like the storm we had here the other night when we were doing the interview. And then you compare that to the storm that wiped out the family in, I think it was Arizona. The reporter that was reporting that said they had a torrential downpour of a half an inch in an hour. Well, here we had an atmospheric compression the other night after the interview. I was still on the phone with you. We got 1.17 inches of rain in 18 minutes.
Wow.
So, that is a lot more. It's what, where I come from, they call a gully washer.
Mari
Definitely.
shot this footage here in Buffalo, Lee. These are skies that they're not used to see. I know some of you in the South think, yeah, that's a typical thunderstorm system, but this is not a normal sky for Western New York. And there was a lot of low-level clouds. There was a lot of funnel-looking clouds. I
was looking for a tornado because there was a tornado alert, and we never get tornadoes, like, ever. So when I saw how the skies looked, I was like instantly, all right, like, let's see, what's going on and which way it's going. And that was pointed, like, right sort of where Jake was working, and I was a little alarmed.
Well,
this storm went on a couple hours. It started, and the temperature change. Was significant. We were in the upper 70s, I think around 79, right when the storm hit, and an hour later we're sitting at 61 degrees.
Well, we're not getting the heating in the upper atmosphere like we used to. And when you talk about all the different things that you had to add up, like we did in the interview, yeah, TSI is one factor. And then cloud nucleation is another factor. And then refraction from that cloud nucleation is yet another factor. And,
wow, look how fast that's moving.
Yeah. And, the point that I've been trying to make out of all of this is that, okay, yeah, so the TSI does fall to 1360. Well, hell, we're almost there now.
Yeah.
The way we've been falling over the last week. And then you've got the increased cosmic rays at the highest levels ever recorded since the satellite era began. Then you've got increased nucleation, which gives you more refraction And I believe that all of that is going to play together to give us a much, much worse time of it than they had back during the Maunder minimum. And, you know, I think a lot of the things that transpired back in those days weren't recorded, you know, and the United States was not highly populated. So, you know, a lot of this news never got out, never got reported, never became part of the archives of what transpired. And I think that, you know, the weather was a lot worse in the United States than what it was portrayed as being. And I think this time it'll be even worse than that. And I think it'll be that way globally. You know, I see us going colder than the Maunder minimum. And when you do go colder, yes, the Earth has heated for a long time, but we're only talking about the surface temperatures. And yeah, it's great if the Earth's core is a little bit warmer, but when you're talking about the surface temperatures, I think in a matter of 10 years of extremely cold, you know, high refractivity, low TSI, with substantially, you know, colder air coming down from the stratosphere and helping to chill the surface of the Earth. We're also on the downward trend for the PDO, the Pacific Decadal Oscillation, the AMO, the Atlantic Multi-Decadal. Yeah.
That was in New York, Hamburg.
Yeah, that's some pretty crazy weather those folks are having. And yes, that is a tornado that went over and created that vacuum to pull that car up.
That's what we thought too.
So, yeah. So, yeah, absolutely. They went right over that guy's house. That's the luckiest man in New York today.
Here's the some of the footage of the China storm that we had showed you earlier too.
Right.
And again, this is stuff that's not covered in mainstream media, nor is it available on the internet. Mari found the majority of this footage on social media like Twitter and Facebook. Like that's the only areas you're finding footage like this.
And so what happens and what you're seeing here is this is like an atmospheric compression event, or if you have like a typhoon or a hurricane and you've got substantial rains coming down, that creates a vertical air column that is moving down at a substantial rate. And when it impacts with the ground, it has to go somewhere. So it goes out horizontally. And, you know, so you've got these rain bombs. And what happens is when it goes out horizontally, you get it and it comes into these cities, it funnels all of that air or wind down into these narrow passages, which extremely increase the velocity of those winds. And you get horizontal sustained winds excess of 120 miles an hour. And that's what you were seeing right there with that wind blowing through those doors that way, is the atmospheric compression creating the rain bomb and the horizontal winds coming out from that are associated with that vertical column of water coming down. And it just blows out to the sides. And here, you know, there you see 4 inches, 5 inches, 7 inches of rain in an hour that just inundates. And here it is again, China, which is where we talked about high pollution, increased galactic cosmic rays, increased nucleation, more rain, heavier storms, worse storms. And here you have a prime example of it.
I read somewhere that the winds were stronger than a really strong typhoon. I mean, what do you?
Oh yeah, they've already been recorded. I mean, what you're seeing right there, that's well in excess of 100 mile an hour. Okay, that rain is coming through that window, that door, and is actually moving up with the pressure and the velocity, and it moves up because the pressure of it coming through is greater than the pressure inside that room. And so it expands out as it comes in, and that's how you get that rain that's actually looks like it's going up as opposed to going horizontal through the doorway. That's well in excess of 100 mile an hour winds doing that.
And you know what was unfortunate is that particular storm, there was 4 sentences that mentioned the storm, and it was very vague. There was no details of how much rain fell or how fast the winds were clocked. But the last two sentences of the report, and it was only 6 sentences long, but the last two talked about the big, beautiful rainbow after the storm and how gorgeous it was. But it failed to give, you know, any details whatsoever. And just another example of people not getting the full story. The whole story is not being told here. This is also,
well, again, it's out of China, so you're not going to get a whole lot anyway.
No, they're very censored over there, and that's unfortunate. But I'm shocked that we even got this kind of footage on social media. So, is there any questions in the chat yet?
They want to know. One person asked if that's the same as a microburst.
On what?
No, a microburst. It's kind of like a microburst, but a microburst is more with air currents than rain. You can have a microburst with rain, that is possible, but most of the time when they talk about a microburst, it's just a downward air column. This is a little different. This gives effects like a microburst, except for it's in most cases much larger, much more turbulent, and is created by the rain falling out of the cloud from the electrical discharge from the ground. So as the cloud is going over and you have a significant lightning bolt, because when you have these atmospheric compression events, the particles that interact, there's more particles, so it shares the water amongst the particles. And so the droplets are smaller, thus they are lighter, thus they can travel much higher in the atmosphere at a much greater velocity, which generates even more static electricity within the cloud. And then you get even larger lightning bolts that are of positive lightning. And then as that electrical discharge takes place, the droplets release from their static tension. And as they are all falling, they pull the air down with them and create these downdraft events known as rain bombs. And when they have the atmospheric compression, that enhances or enlarges both the area that it covers as well as the amount of precipitation that comes from the cloud over the period of the storm. So the rate can be much, much higher, whereas that, you know, people used to freak out with a ½ an inch of rain an hour. Now we're seeing 7 inches of rain in an hour. So, you know, 8 inches of rain. So these are unbelievable events of what literally are referred to as biblical proportion.
Yeah. And Mari and I found this story 3 days after it happened. Here, what we're showing in Spain with the hail and the flooding and how bad it got. And at 3 days after, not even the Weather Channel or AccuWeather or CBS News or anybody mentioned even a paragraph about this story. And to this day, I don't know if there has been any major news networks that's reported on this, but this is stuff here that's not being reported. This is scary stuff. I mean, look how deep this is. That's waist high. The hail, I mean, it melted and it caused the flood. You'd think this would be newsworthy. I just don't understand.
Yeah, you would think, but they're not going to cover it. You know, it's people like us that are going to tell the truth. The corporate media structure is bought and paid for, and if this is not part of their agenda, you can't pay them to put it on the air.
It's obvious. It's obvious with this stuff right here not making it to. I can't imagine why this wouldn't be newsworthy. These are amazing pictures right now. We're looking at this. We're talking about Spain. This was hail. This all started as hail. There's footage. I think, is there footage in here where they're like shoveling through it at some point? I think we have footage that shows it here in a little bit that they are shoveling through. But Lee, I wanted to make sure. When the grand solar minimum does begin, that is approximately the beginning of cycle 25. Here's the footage right here. That's the hail. Look at that.
Right. This is the hail, but I'm saying the grand solar minimum has already begun. It began when we had the second peak that was higher than the first peak during the solar cycle that we are currently in. So the day that the second peak exceeded the first peak, even before it reached its peak, the day it exceeded its first peak, we knew we were done.
We showed
That was that. So that was, and we showed that in the video with John Casey. And so that's when it began. So now we have to go through 3 solar cycles after the one that we are currently in. I'm predicting that those solar cycles will be every bit of 13 years each, if not 14 years. And we won't see, during the next solar cycle, we won't see but 25 to 50 spots at most, depending upon how they manipulate a single pixel as counting it as 11 sunspots. But we will see during our next solar cycle of 25, we'll see 25 to 50 sunspots at most during that solar cycle. The following solar cycle, I don't think we will see any sunspots whatsoever. And then the solar cycle after that will be 25 to 50 at most.
I appreciate you clarifying that for me. There was some misunderstanding on my part. I always thought that the I guess the real effects will be seen in the beginning of solar cycle 25. I guess that's what I'm implying. But I understand what you mean now by it beginning after the second peak. So the technical status of the grand solar minimum did begin.
Yeah, you can go back and determine the date and hour and everything that it started.
But the real, I mean, we're really going to see things swing into gear by the time we get to solar cycle 25.
Oh, we're going to see it long before that. We're revving up the truck now.
Yeah, this is crazy. Look at
yeah. And this is only going to continue.
I'm not trying to exaggerate this. I've just never seen tornadoes.
I want to clarify with everyone too. All this footage has been within the past 3 weeks.
Yeah, within the last 3 weeks.
Just 3 weeks, and most of it actually has been within the last week. I did throw in some other things I wanted to highlight, like from Spain.
That doesn't even look real.
But most of this is from the past week. There's a couple clips that are from 3 weeks ago. This is all recent.
Wow.
Yeah, that's insane. But I mean, we're going to see a lot more of that. And, we're going to see more electrical events. We'll see more discharges. We'll see more, how shall we say, electromagnetic interference in the forms of small EMPs. There's a lot of things that are coming much, much faster than I thought. Oh, and the video that the woman posted today where it looked like Aurora Borealis during the daytime.
Yes.
That is particles just streaming in and creating nucleation before your very eyes.
Wow.
I was absolutely astounded to see that. I never thought I would see that before 2020. So, a lot of the stuff is coming faster than I anticipated.
Mari said that video gave her chills.
There's good reason for that.
Yeah.
There's very good reason for that video to give you chills. When you can see the energy flowing through the plasma, flowing through the sky right above you, yeah, that should give most people chills. To see that and it be intense enough that you.
And and we're not bringing all this to the table to scare anybody. We're bringing this to the table because nobody else is. Nobody else in the mainstream media is talking about these weather events, and these look more like a late spring type storm systems. We're in the middle of July and late summer. These storms are powerful.
Oh yeah, very. And they're going to continue to get even more powerful. as we continue on. I mean, what we're seeing is just the beginning of what is coming, and these are very weak storms compared to what we will have.
You know, cloud coverage and lower TSI and these freak weather events that we're having, as much moisture that we have got this year in 2017. I can speak for the northeastern part of the country. It's been wet. And I can also say the same for the southeast part of so really the eastern half of the United States. I've never seen as much rain as we've gotten. And I know, logic for me anyway, my understanding, it's a lot harder to heat when you have moisture on the ground, and especially if the ground is saturated. So you've got less heating possible through that, not counting the lower TSI. So what TSI that does come on our planet is being reflected back by the cloud coverage that we have, and it's already more than noticeable right now. So you know, no matter what kind of warmth that we have right now on this planet, the next 3 solar cycles, at least 42 years, I don't think that whatever warmth we have now could withstand that, especially like we mentioned earlier about the TSI already being at 1360 right now.
Right, and I continue to think that it's going to continue to go lower than that. I don't see how it cannot continue the downward trend that it has. I've been telling everybody, you know, ever since we started getting these coronal holes, that as these coronal hole streams grow in size, they are going to continue to lower our TSI. And it's going to just keep falling off and falling off. And when you look back at the Valentina Zarkova's work and you look at the opposition and the polarities, wow, this opposition is different than the others. The others were segregated, whereas this is just everything is against itself. And so all of the magnetic fields are fighting each other and nothing is working together. And when it's all working together is when we have higher TSI. And when you've got all 4 magnetic fields going against each other inside, you know, as far as fighting how everything is going against it, or excuse me, the 2 main fields, there's 4, but we go by 2 main, and Valentina's work is why I'm saying it that way. But when you have those 2 main fields fighting each other, it creates a really weak magnetic field on the surface, and you don't have the magnetic umbrals like you do to create all of those sunspots that we have, and you get larger coronal hole streams, and those coronal hole streams are putting out more particles, and at the same time, because those coronal hole streams and coronal holes themselves are cooler, it's reducing the TSI. And that has been my prediction for a good period now, well over a year, that we would be doing that. Probably actually closer to 2 years, I would say would be my prediction on the coronal holes and how they would grow and lower the TSI. And I'm seeing it. And I think that it's becoming obvious to other people as well, especially with the unbelievable rate of decrease in TSI that we've seen over the last 2 weeks, the decrease in the solar wind speed, as well as the decrease in the charge of the magnetosphere. So all of those indicators of the health of the sun are going south simultaneously.
Wow. And just watching this footage here and seeing the storms, and you know, South Dakota is an area that gets thunderstorms, but just watching the amount of hail that's falling here and how big it is and how much it's coming down. Imagine what this did to a field that had crops in it. You know, forget about all the damage of the property and your vehicles. I mean, think about the damage if there are any crops growing in the area. You know, would this be a type of event? Could that ruin whatever you're growing, whether it be wheat or corn? Or
well, did you see where it killed all the livestock? Did you see the pictures of the car? There was here in the United States, there was a hailstorm. I was looking at it 2 or 3 days ago. It looked like shotgun blasts through the car. Looked like you're taking a 12-gauge shotgun shooting slugs and blew holes in the windshield, big enough to stick your fist in your arm through and all the way up to your elbow. Just through the windshield of what the hail did. Holes in the car. And there was a picture of 3 sheep laying in the field that the hail came down and knocked the sheep in the head and killed them. I don't know how many sheep total that it killed, but there were 3 in that one photograph. So, you know, I mean, it does damage to the trees. It does damage to any crops that are in the field. It does damage to vehicles. It damages everything. Whether if it's above ground, it's going to be destroyed. You know, and that's, you know, one of the reasons that I highly recommend that the plants that you put in your garden and the plants that you as a farmer need to be producing need to be root crops. Things like potatoes and carrots and other things like that, that you can knock them down and they'll be able to come back like a potato does. If you don't have something like that and you continue to have storms like this, you won't have a crop. And then look at that damage. That's the side of a building.
Yeah.
That's just the wind blowing it against the side of the building.
Listen, I was an insurance specialist for a remodeling company, and our specialty was meeting with insurance adjusters to get roof spot, siding spot, gutter spot, etc. We were there to get the storm damage repaired. And I could tell you right there, folks, that kind of damage that's what Lee's saying, biblical. That right there is unheard of and unseen, in my opinion. I've never seen anything more severe. That was hail damage as well on that siding. So that wind's blowing really hard and that hail's hitting the house. Again, I've seen training videos about what severe hail damage looks like on some of these houses. I didn't see anything in those training videos that showed us that stuff that looked like that. That's crazy. I think this here is a path of all the damage from the hail. Oh my goodness. 60-mile hail scar. So
yeah.
If you're in the roof,
you know, and that's the ground. If all of that were crops, that all of that would be devastated. Okay, that's over 100. That's probably close to 200 square miles easily, maybe even more than that, of area that was devastated by that single storm. That any of that area that you saw was brown is destroyed ground, that all the crops would be gone.
All right.
So yeah, 100,000 lightning strikes have been recorded in England and Wales.
Yep.
And so
you were telling me about this. Wow, look at that.
Okay, that storm right there just broke the world record of the most lightning strikes. 250 lightning strikes per minute. Okay, the old record was 3,600 lightning strikes in a single hour. That was in Brazil near a lake. And this lightning storm was putting out more than 10,000 lightning strikes an hour and did it for more than 10 hours.
My gosh.
So, yeah.
I'm surprised we haven't heard of any injuries or deaths from that
they're not
storm.
going to talk about, this is unbelievable, the amount of lightning that was present within this storm. And this is only going to increase as far as the size of the lightning bolts, the number of lightning bolts, and the devastating effects that they're going to have on electrical grid and infrastructure and buildings and vehicles. I mean, you know, when I was growing up, if a car got hit by lightning, so what? You know, now we had people get injured in India the other day. They were riding a train and a lightning bolt hit the train and injured people in the train. You know, that's kind of unheard of. You know, lightning bolts destroying cars. There was one of those little Priuses that was hit by a lightning bolt and literally blew the front part of the car apart.
Wow.
When the lightning bolt hit it. You know, this is totally different than what it was when I was a kid.
I saw mention this morning on Weather Channel, or I can't remember if it was Weather Channel or AccuForce. They did mention they did mention one of these flood footages, but the amount that Mari found, I mean, she could have had probably hours of footage of everybody flooding everywhere, not just here, but overseas as well. And while I'm on the topic of overseas, question was raised, Lee, is the grand solar minimum, is it going to have effects on air travel internationally, especially?
Yes. So you will see effects on air travel in multiple ways. First, you will have the inclement weather that you're seeing right now with these windstorms and hail events and so on and so forth. Eventually, they're going to get worse, and they're going to start going across airports and damaging aircraft on the ground and taking aircraft out of the fleet. That's one way. The other way is these massive storms will close down airports and prevent people from going and flying in and out of those airports. And as they get larger and get strung out across the country, more and more airports will have delays, and that'll cause ripple effects throughout this country and other countries, because some of those airports will be international airports. Then in the more northern latitudes, in this country and in other countries, as well as southern latitudes closer to the poles, well below the Arctic Circle, they will have blizzard conditions, hail, freezing rain, and extreme sub-zero temperatures, which will make operating for the crews on the ground for the aircraft at the airports basically impossible, as well as keeping the runways free of ice and other things, which will shut down runways in airports on northern latitudes. In addition to that, you will also have airports that will be lost because of volcanoes and seismic activity. So as the number of earthquakes increases, you will get more of these airports and major metropolitan areas being damaged. And then with increased vulcanization, you will get areas of airspace that are restricted from flight because of the particulate that is in the atmosphere. So yeah, air travel will be affected. And then the last thing, as far as air travel being affected, and it's probably not the last thing, but it's the last thing I can think of at this particular moment, and that is because of the increase in galactic cosmic rays, air crews on board those aircraft will be forced to fly less hours because they will be experiencing higher doses of cosmic radiation as the amount of cosmic and galactic cosmic rays increases in the decades ahead.
Lee, are you seeing the amount of sprites that are coming up in this one storm? Have you been watching this video?
Yes, and it is absolutely insane. Again, this is all part of it. The electrical balance between the Earth and space and the sun is changing. And as our magnetic field changes and the Earth's energy changes, all of that is going to change. And we are going to start seeing things in the sky that we have never seen before in our lives. And people will swear that it's end times coming, because nobody knows what's happening. The number of people that know the truth, like we do, is very, very small. I mean, you know, we're talking a fraction of a % of the population of the planet knows what we know. And, you know, and the media won't talk about it. And, you know, even the Russians are preparing, and they know that they're preparing for a grand solar minimum, but even in their media, they don't talk about the plasma streams. They don't talk about the increased aurora borealis. They don't talk about the cloud nucleation and so on and so forth. They don't cover all of that because that's not Russian science. Valentina Zarkova and some of the other Russian scientists that are talking about the magnetic instability of the sun and the decrease of the sun's magnetic field and the opposition that will be created as those two magnetic fields go 180 degrees out of phase and cancel each other out. that's the kind of stuff that they talk about. They don't get into the particle physics of it like we do, or the cloud nucleation, or the increase in gases that are created, or how the particles. They don't talk about all that. They just say it's going to get really cold. You'll need the vodka. So
I just, you know, we're looking all over the world, all over the United States. Yeah, floods happen everywhere. I get that. I've just never seen the amount of flood events that we're seeing all over the United States this year. Now, this leads me to a question I had. I was curious. If right now our upper atmosphere is cooling, which is creating these intense rain events, my question is, Lee, and I don't, you may have or may not have an answer for this, but if our atmosphere was warming, would we see rain events like this as impressive? Would it drop these kind of storms if indeed our temperatures were warming in the upper atmosphere?
okay, I got to back up and correct one thing. First off, it's not the cooling of the atmosphere that is causing the rain events.
Okay.
It's the increased nucleation created by the cosmic rays that are coming in. We have a cooler upper atmosphere, stratosphere, ionosphere layer, and we're getting that because we have found that with these galactic cosmic rays coming in, that is creating nitric oxide gas, and that nitric oxide gas is acting as a giant air conditioner up there. So that is a cooler than it used to be, and we're seeing that with the satellites, and have been. NASA reported this in December of last year. I've been jumping up and down and beating on the desk about it ever since, and I still can't get any of the major news media to cover it, even though it was a study conducted by several universities along with NASA and the Goddard Space Flight Center. And it is critical data. But again, it flies in the face of global warming, so nobody's going to touch it with a 10-foot pole. So it's the increase in galactic cosmic rays, the increase in the nucleation that is causing this. Now, if you had the temperature, as far as that scenario is concerned, is irrelevant, because it's all a matter of particles. Now, if we had a more active sun, you would have less particles and you would have less rain. The less active the sun becomes, the more rain you are going to get. And so we are just now, our sun is just now weakening below what it normally does. It's got a long way to go. And this is nothing more than a preview of the worst horror movie that you're ever going to live through in your life. Because this is what's coming. People will thrive and people will not survive. But that will be dependent upon what the people choose to do with the information that they are giving as to whether or not they prepare or whether they don't prepare. And if they don't prepare, they're going to be like those poor people that got washed away in the river. You know, if you do prepare, then you're going to be the one standing on the bank with the rope and the lifeline and the float to throw out to them to try to pull them to shore, because you know what's coming. That's the difference in the scenario here. The people that don't know what's going on are the people that got caught in the river. The people that do know what's going on got out of the river into higher ground in time. That's the difference between the people that don't know and the people that do know.
Look at the moisture falling from the sky.
Oh, yeah.
Unreal.
Well, that's just cheating. That's not as bad as, yeah, you should have been down here when it rained the other day. It was black from the sky all the way to the ground.
Well, I thank you for clarifying that the temperature was irrelevant when it comes to the amount of rain. I think that gives me a better understanding as well of why we're seeing so much. It makes sense to me. The particles obviously have increased. We are in a weaker magnetosphere with weaker activity from the sun. I get that. So that makes sense, and I appreciate you clearing that up for me. I always had the idea or the notion that I thought that the temperature of the upper atmosphere had something to do with the intensity of rain events. But it is indeed the nucleation of the particles. So that helps.
And one thing I do want to express to everybody here, and they need to understand this. Okay. It doesn't matter if our atmosphere is 99.99999% humidity. It cannot rain unless there is a particle that moisture can form on to create a raindrop. That's a seed. You have to have that particle. And that's what galactic cosmic rays make, is those particles. So the more particles you have, the more raindrops you have. And so as galactic cosmic rays are increasing, we are going to have even more and more particles. And because we're going to have more particles, that makes more raindrops. It's that simple. And so when the galactic cosmic rays come in, you have to kind of look at the galactic cosmic rays as, I guess you could you can look at them as like a volcano, because when they first come in and they hit the first time, they kind of like spew out like a volcano spews up in the air. And the more particles that are there, the more reaction you get. And so exhaust from jets, exhaust from ships, exhaust from cars, power plants, anything, even decaying wood, whatever puts particles in the air, even pollen particles, whatever gets up there and those cosmic rays interact with, that creates more seeds, that creates more raindrops, that creates more flooding. And so this is just the beginning, because the galactic cosmic rays are going to continue to go up, and the magnetic field of the sun and the earth are both going to continue to go down. And we're not cutting back on our emissions. Neither is Asia. And it wouldn't matter if we did or not. It's going to be a huge flooding event globally, as well as freezing event, hail, high wind speeds, tornadoes, hurricanes, you name it. If Mother Nature can dish it out, she's going to show it to you now like you've never seen it before. She's been calm, cool, and collected for a long time. Mother Nature normally changes the climate about every 358 years, I believe, is what the average of it is. You know, give or take about 50 years. But it's somewhere along in that line. And so going back through the history of the planet, we've had those dramatic shifts, but man hasn't had that here lately. And because of that, we have grown accustomed to living in our perfect Goldilocks zone with our perfect Goldilocks climate that gives us these great yields out of our field each year. And Mother Nature's about to say, boys, it ain't going to work like that anymore. Now let me show you how we're going to play the game. And she's going to shorten the season. She's going to flood the crops out. She's going to make areas that used to grow beautiful crops into areas that are nothing more than marsh or frozen wasteland. And that is going to require the agricultural industry to move south, dependent upon the continent that they are located on. But if they are north of the equator, they're going to have to move south anywhere from 350 to 700 miles. Same thing's going to apply to agriculture in the southern regions of the globe. They're going to have to move north, because it's going to be a lot bigger problem for the people in the north. I will tell you that the effect of the grand solar minimum on the planet will be much more greatly felt and seen in the northern hemisphere than in the southern hemisphere, just simply because of where we are within our Milosevic cycle.
And you broke it down really good, talking about particles. The more particles, the more rain. And we already know now.
Excuse me, it's Milankovitch. Like, we're going to make sure I get that right, as opposed to Milosevic.
Right.
I have misspoke that before, and I want to make sure I get it right. The Milankovitch cycle.
But thanks again for breaking it down to explain to people that particles are much needed for raindrops, and when you have extreme amount of particles, you're going to get extreme amount of rain. And the freaky part about all this is that we are just in the beginning, and we already know that NASA and NOAA and everyone's acknowledging that the sun's magnetic field and the Earth's magnetic field is growing weaker, which allows more charged particles. And again, we're only at the beginning. So again, we're not here to scare, but this is just the tip of the iceberg. And I guess I have a hard time understanding why there's any kind of disagreement amongst what the grand solar minimum theory is and what's happening. What we're doing here is raising awareness, and nobody else is talking about these stories.
Right, and the difference between us and everybody else is, one, we know what is going on. Two, we can prove it through all of this research. I mean, people can try to cherry pick what we say. Okay, fine, go ahead, cherry pick whatever you want. But if you sit down and do the math, a sixth grader can see what's going on. And it's that simple. You don't have to have a PhD. You don't even have to have a college education. All you have to do is sit down and pay a little bit of attention, watch a couple lectures, and understand what they're talking about in the lectures. And these people know what they're talking about. They're doing lectures on decades of research, and they're showing you the final conclusions. And you can read those conclusions and put them together within your own head. You know, the conclusions are, when you have more galactic cosmic rays, you have increased nucleation. When you have increased nucleation, you have more rain. Okay, that's simple enough. What's the world doing? We're getting more galactic cosmic rays. Why does that happen? Because the sun gets weaker. Is the sun getting weaker? Of course it is. Is the Earth's magnetic field getting weaker? Of course it is too. So everything is all correlated, going together. It lines up exquisitely, as Dr. Kirkby puts it. And if you put the galactic cosmic rays into the chart inverted, so that goes along with the sunspot count, it all lines up perfectly. So when you have less sunspots, you have more galactic cosmic rays. So we are having very few sunspots. And because of Valentina Zarkova's work from Northumbria University, we now also know that the magnetic fields are going to get weaker. And it's not only Valentina. There was other two young, and I call them young, I'm old, but you know, there was two younger guys, I'm talking in their 30s or 40s, whatever, and they came up with the theory also saying that the decrease in the magnetic fields from research that they had gleaned from the Wilcox Solar Observatory in California. They had gleaned from that the magnetic fields of the sun were weakening also. So this is two separate sets of researchers have come to the same conclusion on what is transpiring on the sun, coming at it from two separate angles. And the crazy part about it is they're both right. They're both documenting the same thing. They've done it in two separate different methods, but it does say the exact same thing. And that, you know, both of that work has been, you know, substantiated by other researchers going, yes, it's been peer reviewed and it is correct. The data does support it. The sun is continuing on this trend. So, you know, you can't stop it. And you have to acknowledge that it's happening, because it is. You know, so you can either wake up and smell the coffee today, or you can wake up and smell the coffee when your house floats away. I don't care one way or the other, but before you die, unless you die here within the next couple of years, you're going to know for sure that this is happening. Well, we tell you, or you see it yourself.
And I wanted to bring up too, last week we had an interview with John Casey, and you talk about people who have put decades of research into their work. And, you know, John was pleasant to talk with, but also you could tell in the conversation that John wanted to get the message out, as much information as possible, things that support what we've been talking about, things that Adapt 2030 are talking about. So I look at what we're doing on this channel. There are more than just people like John Casey. And you talk about the big picture, Lee. And the big picture is that we are taking different scientists that study different things, like Valentina Zarkova. She her theory is the magnetic field is weakened, which just supports more of what we're saying on the grand solar minimum. So it doesn't have to be, she doesn't have to support the grand solar minimum ice age theory so much. The fact that she just recognizes the fact that our electromagnetic field is weakening, or Earth's magnetic field, I'm sorry, is weakening as we speak. And then you have people like Dr. Roy Spencer, who, again, not such a man on ice age or anything like that, but what was the main...
He debunks CO2.
Yes, he is also a huge believer that CO2 is not driving the climate. So, you know, when you say cherry pick, it's not cherry. These people that study these fields are formulating the big picture, and it all adds up into the same basket. On top of the scientists that do the research on the grand solar minimum, people like Piers Corbin, PhD. Am I correct on that?
Correct. And he's a PhD astrophysicist, as well as I think he has a master's degree in meteorology. Okay, he understands the electric universe theory. He understands
Absolutely.
everything that is transpiring here. He's just one of many astrophysicists that do that. And what we bring people is known science. Okay,
Right.
You can go get the peer-reviewed documents that are known and accepted science of how it works, you know, as far as, and what do I say by known science? Well, everybody agrees that, you know, 0 degrees C is freezing and 32 degrees Fahrenheit is freezing, and, you know, 100 degrees C is boiling, and, you know, 212 Fahrenheit is boiling. That's known science. That's established
Right.
science. We all work on the same rules. And so everything we talk about on this show, or any show I do for that matter, is all known science. All comes from a peer-reviewed document. The only thing that does not come from a peer-reviewed document that I express on the show is my opinion as to how much worse it will be than the last time, because of what the peer-reviewed documentation is showing us. And then I try to show you where you can go and do the math to come to the same conclusions that I did. So
Well,
that's...
And what, but the problem is that when you originally, you know, did the math and you put you connected the dots, your predictions were true, but they happened a lot worse than what you predicted as well.
Correct. They're coming faster, which shows that the rate of decline is going, and I've been saying this, that the rate of decline is much faster than expected. And everybody's saying, oh no, it's going along and progressing just like it should. You know, as this goes down, that goes up. But if you look at the 3 charts that I just sent you, you can see that the rate of decline is getting faster. It's accelerating dramatically by factors of X, as opposed to it's a 10% or a 20% or a 30%. I'm talking it's dropping fast compared to what I thought we would see. The drop off that we are at today, I did not expect to see until the year 2020.
Yeah, that's concerningly. Yeah. I mean, and again, I'm not trying to act like there's nothing to be worried about. We saw a 0.21 degree temperature drop in June. You know, I don't care about that we're still above or in the warming trend. Why, Lee? Why do you think?
I know it dropped to 0.21, so we are now 0.21 above our average. Okay, so it was 0.34 or whatever it was above that, and we dropped to 0.21 above our average for the coldest that we get. So we are moving down much faster than what we should be moving. I've been calculating the drops, and I was not expecting to be down to 0.21 at this point in the year. I was expecting to be at 0.18 by the end of the year, and we are only 0.3 or 0.03 of a degree above what my year-end prediction was. So we're going to exceed the drop of my prediction by a significant amount. And when the last report came out, not this past one, but the one previous to that, that came out for May and showed the drop in May, that's when I changed my Facebook page and started putting that up there, because I knew right then and there we were in trouble.
Hey, Lee, I got a couple of questions. Mari, go ahead and read off a couple of questions that we got in the chat.
Yeah, just do them one at a time.
Mystery just wants to clarify the particles in the atmosphere. Do all the particles turn into raindrops? She wants to have that clarified.
No, not every particle will turn into a raindrop. Just like putting seeds in the field, not every single seed comes up. But the more seeds you put in the field, the higher your population. So the more seeds that we have up there because of the nucleation, the greater amount of raindrops we will have. And it's a combination of conditions that have to be present to create a raindrop. You know, the particle has to be large enough. The temperature has to be right. The amount of moisture has to be right, or the humidity in the air. So there's a variety of factors that go into the formation. But once it starts, if you have additional nucleation in the area, those particles will share the moisture load with those other particles. And when it does that, you get a lighter raindrop. You also get a lighter colored raindrop and a lighter colored cloud. And that gives you increased amount of refraction of TSI back out into space.
And then we have a question about the iceberg that broke off recently. There's been some debate whether or not this is something due to temperature or if it was a natural progression.
No, it's a natural. It's a natural. It's so big because that's how much it grew.
So the question is,
calving.
Do you think there'll be more icebergs breaking off? That's
absolutely, absolutely. And the icebergs, not only will there be more of them breaking off, there will be, because they're going to be growing. But not only will there be more of them breaking off, they will be moving further and further south from the northern waters. So they will be moving. In fact, just the other day, icebergs were tracked south of where the Titanic went. And so we haven't had icebergs up in that region for quite some time. And so the furthest south icebergs that we've recorded in the last 100 years have all been recorded in the last 6 months. And that's just the beginning. Before this is all done, you'll see icebergs floating past New York City.
Well, and you know, that's another great thing that I don't know if a lot of people knew, that the reason why this shelf broke off was because of it grew the weight.
Yeah, it's calving.
Again, the mainstream media will tell you that it's because it's melting.
Well, that's they can tell you whatever they want. The truth of the matter is that the Antarctic ice sheet has been growing. It would be growing much, much more if it weren't for the fact that to the western side, there are some underwater volcanoes that are heating the water on that side and creating some melting. But as far as the east side of it, and the north and the south side, they're still, you know, kicking it as far as making icebergs and increasing the amount of snowpack that they have. Those glaciers are growing. This is breaking off, and it's a normal process. They grow, they float out, they get to a point where the ocean is moving, the tides are getting it. It gets a weak spot, it starts a crack, the crack goes all the way up through, it breaks off, it floats away, and we start over again. It's done that for hundreds of millions of years and will continue to do so. It's just going to be worse now, especially on the northern side, because again, because of the Milankovitch, not the Milosevic, Milankovitch, because of the Milankovitch cycles, we will have a greater effect on the northern hemisphere of the Earth as opposed to the southern. And some places will be warmer. Some places will be just like they were before. Some places will be much, much colder. On average, everything will drop in temperature. And we will have temperature extremes. We'll still have our 4 seasons, okay, in most places. But those seasons will be all mixed up. You'll have, like the farmer had, a really, really, really warm February, brings the buds out, And then in March or April, it'll freeze and kill them all. So that's how you will lose your
bigger problems.
Huh?
And that leads to much bigger problems.
Correct. And we've already experienced that this year globally. This is just the tip of the iceberg of what we will be experiencing in the years to come, decades to come. I mean, we're talking, look, we've got 40 years of this, and we just got started.
Wow.
And the crazy part about this is after that 40 years, it won't matter, because when we come back up, we're not going to come back up like we should because of the long-term trend. The long-term trend says we should be cooling and it should be colder. And by the time we come out of this, half a century from now, then we're going to be, farther down on that long-term trend. So when we do spike back up, it won't be anything like what we see right now. In fact, I agree absolutely 100% with John Casey when he says you have lived through the warmest days you will ever live through in your life. Because nobody alive on this planet today will live in a climate warmer than it is today for the rest of their lives. Don't care how old you get to be. We're not coming back out of this. So enjoy your summers, enjoy your warm weather. You will still have summers. You will still have warm weather. You will still have hot stuff. But as far as the average temperatures that you are feeling on the planet, they're as warm as they're going to get right now.
Well, and again, the big picture is all about domino effects, what to do if we get into a food shortage crisis. There are parts of the world that are having those problems with keeping produce on the shelves, keeping it stocked. Some places are bare. It's important to have alternative resources for food. Tomorrow night, we are having Ice Age Farmer along with Lee Wheelbarger. We're going to talk about crop growing. But really, I want to take a minute and thank everybody for supporting the Grand Solar Minimum channel. And the support that we got for the John Casey interview was overwhelming. John's a great guy. He does good work. I wish there was more people like John out there, honestly. And I just want to say thanks to all the people out there who watched the interview, who have probably watched it more than once, our moderators who are in our chat right now, helping keeping things on topic. Guys, this has been a team effort from everyone. Mods, Mari, I give her the most credit just because of her ability and what she does and what she brings to this channel when it comes to the contacts and the contents and the video editing and the presentation and the long hours of editing and video compilations that she puts together. But again, John, thank you if you're listening for being on our show. We hope to do it again. And Lee, with that, do you have anything else you'd like to add?
No, I just hope, that everybody, as opposed to, sending checks, just send our videos and our interviews to your friends, your families, your coworkers, your bosses. Everybody on this planet is going to have to live through this or die in it, one of the two. And, it's better to be prepared than be scared. Let's get the truth out. Let's share what we know. Let's all work together the best we can to survive this, because if we don't work together, very, very, very few people will be able to survive it alone. It will have to be a team effort, and people will have to come together like they've never come together before and create a bonding within your community, your friends, your family, your associates, your employees, your employers. So, we need to pay close attention to what's happening in the weather, pay close attention to what we find out with the data, do the math for yourselves. We'll show you where the documents are to go look at that. We'll show you where the lectures are. You can watch all the lectures, the same information that we're getting. But we want you to draw your own conclusions. All we're asking is that you have an open mind and look at the facts. Look at what is proven science. Look at what the scientists are saying. Don't look at commercials. Don't look at advertising. Don't look at major media. Look at what the scientists say in their lectures, because that's the only place you're going to get the truth.
And
that's about all I got.
Again, thank you, Lee. And the point of this channel and tonight's program as well, and the reason why I brought the crop stories up first tonight was because I don't want people who follow this channel here on YouTube, Twitter, Facebook, wherever, I don't want that, we've never seen this, I wasn't expecting, I don't want that surprise factor to happen to people that are paying attention. I want people to be prepared, because you could, it was heartfelt. You felt sorry for the farmer. You could tell just by the way the reporter was writing the story that this was brutal. And the purpose of this channel is to make people more aware. And that's why we're having programs like tomorrow night with Ice Age Farmer and alternative things to grow. So, guys, that being said, thanks again for watching, listening, wherever you are in the world. We will be back tomorrow night, 10 p.m. Eastern Time, with Ice Age Farmer and Lee Wheelbarger. This is Jake Amari signing out. We'll see you guys soon.
Good night, everybody.